Okay, so for our next problem, step 1 says distribute and combine like terms, but there's nothing to distribute or combine like terms on either side. Step 2 says if there are fractions, consider multiplying by the LCD to eliminate fractions. Let me show you how that works. So to eliminate fractions on both sides, the first thing I want to do is make all terms into a fraction. So the 9, which is a whole number, make it into a fraction by putting it over 1. Now I'm going to look for the LCD. The LCD is the least common denominator between 1 and 5, which is 5 because 5 can be divided by 5 and 5 can also be divided by 1. So the LCD of 5, what I'm going to do with that LCD is I'm going to multiply it to every single numerator on the left and every single numerator on the right. So when I multiply it, what happens is something that means that all the denominators are going to cancel out nicely. The reason I'm allowed to multiply it to both sides is because of the multiplicative property of equality, because there's an equal sign here, okay? So back when we were learning about fractions, about how to add fractions, multiply fractions, divide fractions, add fractions, we weren't allowed to just multiply the top by something. Well, I'm allowed to because of the equal sign. This is not just regular fraction work, this is equals, or solving, which means I can use the multiplicative property of equality. What happens here is the 5 in the numerator and the 5 in the denominator divide out nicely, and I'm just left with 3x, no fraction. Hooray! On the right side I have 9 times 5, which is 45, and 45 divided by 1 is 45. So from one step I've turned it from a fraction into a whole number problem. Yay, I like that. Now the next step says get all the x's on one side and numbers on the other. Done. I've got the 3x on the left and then 45 on the right. So all I need to do is step 4 with the multiplicative property by multiplying by the opposite. So this is a multiply by 3. So the opposite of multiply by 3 is divide by 3. So as long as you divide to the left and the right, you're okay. So 45 divided by 3 is 15, and that is my answer. I'm going to go ahead and check this one. So we have 3/5 times 15. Remember that 15 can be rewritten as 15 over 1. And I'm going to check to see if that's actually 9, or really 9 over 1, okay? So now I have, let's see, oh, the 5 and the 15 can reduce. That's divide by 5, that's 3, divide by 5, that's 1. So now I have 9 over 1 equals 9 over, this is true, so 15 is my answer. Let's try this again on the next problem. Step 1, there is no distributing, but if I distribute, I would do that first before you get rid of the fractions using the LCD trick. Step 2, are there fractions? Yes, there is. What is the LCD between 2, 3, and 6? Well, the answer is 6, because 6 can be divided by 2, and 6 can be divided by 3, and 6 can be divided by 6. So what I'm going to do is I'm going to multiply every numerator by 6. The reason I'm allowed to do this is because there's an equal sign. Because there's an equal sign, that lets me multiply the left and the right by anything I want. I choose the LCD. And the reason I choose it is because it's going to make all of my denominators divide out nicely. So I have 6 times 1x over 2. So notice the 6 and the 2 divide out to 3. And then I just have 3 times 1x, which is 3x. On the next one, the 3 and the 6 divide out to 1 and 2. So that gets me 2 times 2, which is 4. And on the other side, I have the 6 and the 6 divide out, and I'm just getting 1. So step 2 is done. Now step 3, use the additive property of equality to get x's on one side, numbers on the other. So I'm going to make my x's on the left and my numbers on the right. Who's on the wrong side? There's only one term that's not already on the right side. It's the -4. It's a number and it's right now on the x side that I've labeled, so I'm going to do its opposite. Because it says -4, the opposite of -4 is +4. So I add the opposite. That leaves me with 3x on this side. The -4 plus 4 adds to 0. 1 plus 4 adds to 5. Okay, so the x is closer to being by itself. The reason it's not exactly by itself is because it's got a 3 in front. So now step 4 says use the multiplicative property to get rid of that 3. Because it's multiplied by 3, you do the opposite, which is divide. So my answer is 5/3. X equals 5/3. I'm going to go ahead and check this one. This may be the last one I'm going to check here. As the problems are getting harder, Notice that when you take the x and plug it in as a fraction, it's like already a lot of work, okay? Just because it has fractions. So 1 times 5 is 5, 2 times 3 is 6, minus 2/3 is supposedly equal to 1/6. Now, this doesn't have a common denominator, so I am going to make a common denominator of 6. So I'm going to multiply this one by 1, so that's 5/6. Multiply this by 2 and get 4/6. And does 5/6 minus 4/6 equals 1/6? Yes, it does. So 5/6 truly does check out. But do you notice how these checks are getting harder as your answers are becoming harder, like fractions, your checks are getting harder? Which is why I say the checks are just optional. Not just because they're hard, but because sometimes in math checks are required. In this case, checks are not required. This is just to make sure you're doing it right. On our next problem, we have to distribute and combine like terms on the left. Notice that there's a negative or -1 here. I'm not distributing the 5 through. I'm distributing just the negative. So that gets me 5 minus 2x minus 6 equals 9x minus 19. I can combine the 5 and the -6, and that becomes -1. I'm going to make one side to be the x side and the other side to be the number side. I often like the x's to be on the left and the numbers to be on the right, but technically you could rearrange those. I don't really care. You just need to label one side to be x and label the other side to be numbers, and this don't change your mind. Halfway through the problem, if you change your mind, it's just a lot more work. Okay, so who is on the wrong side? It looks like -1 is on the x side, and that belongs on the number side, so I'm going to add its opposite. Because it's -1, I do the opposite, which is +1. Let's see if we can do 2 steps at 1 here. Who else is on the wrong side? It looks like 9x is on the number side, and I want it to be on the x side. So if I do the opposite of positive 9x, that's minus 9x. This is the first time that I've tried to do 2 steps in 1. If you like, you can do it in two steps, and that's fine. -2x minus 9x is -11x. The 1's add to 0, the 9x's add to 0. -19 plus 1 is -18. And step 3 is done. I've got all the x's on the left and all the numbers on the right. Now x is really close to being by itself. It's not by itself because there's a -11 in front. So the opposite of -11 multiplied by -11 is divide by -11. Now a negative divided by a negative is going to be a positive. So 18/11 doesn't reduce to anything other than 18/11. So x equals positive 18/11 is my answer. I'm going to go ahead and leave that check to you. The longer the problem is, the longer the fraction is, the check becomes a little bit long and hairy, so I'm going to let you do that on your own. I will give you a spoiler alert, it does check out, and that is the correct answer.